This video is to help you solve quadratic equations using the quadratic formula. This is the question from your classwork for solving quadratic functions, so this should help you complete it or review for your test, which is Friday. The first thing that I want to do when I start a problem like this is identify A, B, and C. Now, A is the number in front of x squared. When there's no number in front of x squared, it's 1. B is the number next to x, and it's -4. A common mistake I've seen is that we're neglecting the negative. So we need to remember to include the sign. And then C here is the last number at the end, and it's just 1. So what I'm going to do is color code my A, B, and C to match my quadratic formula up here. So A will be in pink, B will be in yellow, and C will be orange. Now on the test, I encourage you to use highlighting so that you make sure you're putting each number in its right position. So x equals, and remember that there's always a negative out front, so a negative, and then b right here is -4, so I'm going to put that in a parenthesis, plus or minus the square root of b squared, so I'm going to pick up b from here, minus, and this is always -4, a, which is 1, c, which is also 1, over 2a. So a is 1, so I'm going to write 2. So the first step is to set up your problem. You want to make sure that you've set it up correctly, and I would double check by highlighting the numbers with their proper color. So once you've double checked your work that you've put each number in its correct position, you want to get to solving. So you start the next line. Now a negative and a negative make a positive. So now we've got +4 plus or minus the square root of. And rather than doing this out here, I want you to start practicing typing all of these numbers into the calculator in order with an open parentheses, -4, close parentheses, squared, -4, open parentheses, a, close it, open again, c. Then close it. You hit enter, you'll get the number in here, which should be 12 over 2a. So 2 times 1 is just 2. Now, 12 is not a perfect square, so what I need to do is grab my factors list, which if you do not have, please let me know and I will give you one. And we want to look for which one of these has a perfect which one of these factor pairs has a perfect square. So I'm going to write all of the factors here on the side for the root of 12. So I've got 1 times 12, 2 times 6, and 3 times 4. Now, what I want to do is look for the one that has a square factor. And I notice immediately that 4 is a square factor because the square root of 4 is 2. So I get to cross off all the other factor pairs and I'll be working with this one. And what I'm going to do is put a radical on both. And now I'll take the square root of 4, which is 2. And since the square root of 3 is a decimal number, I have to keep it inside the radical. It doesn't get to come out because it's not a perfect square. So leave it like this. At this point, you've simplified your radical and you're ready to get back to solving. So, I've got x equals 4 plus or minus 2 root 3 all over 2. Now I'm almost done, but I noticed that my 3 whole numbers, which I'll circle, all have something in common, which is that they are all divisible by 2. So what I'm going to do is divide all of my numbers by 2. I'll start with the bottom. 2 divided by 2 is 1, so I get to cancel it away. 2 divided by 2 is also 1, so I'll cancel that one away. And 4 divided by 2 is 2. So now the 4 became a 2. So I've simplified my expression, so now I get to write x equals 2 plus or minus the root of 3. And at this point I'll branch out, and on this side I'm going to write x equals 2 plus root 3. And here I'll write x equals 2 minus root 3. And you're done. That's how we solve. Now, the trickiest part might be remembering to simplify your radical, but because the root of 12 is not a perfect square, we had to go through this extra step. Typically, you would not have to do this, but that is just a little bonus step. So, hope this video helps.